All right, so I just wanted to walk you through a few basic examples really quickly. So you're going to see on the notes that I gave you the definition of a relation. And this isn't a very mathy definition. It just means a set of ordered pairs that are hanging out together. I know that's a very unmathy definition, but that's all a relation is just a set of ordered pairs. And so a couple days ago, we were given a list of ordered pairs and asked to put them into a table first. So just a reminder about how we did that. So on a table, your X goes on the left-hand side of the table, your Y goes on the right-hand side of the table. So for this first coordinate, -2, 3, we're just going to graph it, or we're going to write it, right there on the table. So it just says -2, 3. Our next ordered pair was 4, 5. So we just write it in the table just in order, 4, 5. And then 4, 6 went next on the table. And -1, 9 goes next on the table. So that's where those numbers from the table came from. Couple of pointers. Okay, when you're doing the numbers on the table, the order is not important. So what I mean by that is it's okay that this doesn't go least to greatest. It's not necessarily in order. So as long as you've got the ordered pair, so -2, 3, -2, 3 is next to each other. It doesn't matter what order you do your X's or your Y's in. The order does not matter. Now let's look over at the mapping now. So on a mapping, the X values are on the left-hand side of the mapping. Your Y values are on the right-hand side. So you can see and the first thing you do is you need to write all of your X values on or in the left-hand side of that little oval shape. So the X values that we have, if we zoom in here, we see we have -2, we have 4, and we have -1, right? So when you go over here to the mapping, we have 2 4s in our list, but we do not repeat that 4, okay? Even though it appears in the list twice, you only write those 4s one time in the list. Then we're going to write all of our Y numbers on the right-hand side of the mapping. So then the way that you see how they go together is that's what those arrows are for. So you'll see that on my first ordered pair, -2, 3, I drew an arrow from -2 to 3, so you know that those go together. 4, 5, I just drew an arrow from the 4 over to the 5. 4, 6, we just drew an arrow from the 4 to the 6. And -1, 9, we just graphed we connected them with an arrow. So for the mapping, you write all your X values and all your Y values, but if you have anything that repeats, you do not repeat it. And then you just connect the X coordinate and the Y coordinate with arrows. And then finally for the graph, this part, I feel like we've got this down pretty much. So but just to make sure, my first coordinate, -2, 3, we went to, because that first coordinate was the X coordinate and it was a negative number, we went to the left 2, and then we went up 3. So that is where the ordered pair came from for 2, 3. Then my next coordinate was 4, 5. And because both numbers are positive, we went to the right 4, and then we went up 5 to get 4, 5. To get the 4, 6, because those are both positive, we know we went to the right 4, and then we went up 6. So that's where that coordinate came from. And last but not least, -1, 9, because that 1 was negative, we went to the left, and then we went up 9 because that was a positive 9. So the first part, we just need to know how to represent the ordered pairs in each of those 4 ways. So that's what we learned how to do first this week, was just the 4 different ways to write a relation. And the other thing I should mention in the mapping too, the order doesn't matter here either. So for example, even though I put my X's in order from least to greatest, and I put my Y's in order from least to greatest, it really doesn't matter whether you write them in order or not. Okay, and so the reason I wanted to bring that up is because the last thing I'm going to ask you to do is to find something called the domain and the range, and when we do that, order does matter. So I'm going to scroll down here. And so for our final example, so you've got 4 different words. We've got independent variable, input, X value, and domain. These all mean the same thing, okay? The word we're going to use here in algebra the most is the word domain, though. Even though it means exactly the same thing as independent, input, X value, domain, they all mean the same thing. But in Algebra 1, we use the word domain more than any other word. So what is the domain? It's your X values in order least to greatest, and do not repeat. So, and they have to be in those little, oh, those are really ugly, those little curly Q braces that I can't draw. So let's look at our example up here. So the 4 numbers we have on our x-axis, we have -2, 4, 4, and 1, right? Those are our x values. So -2, 4, 4, and 1. Okay, so those are my X values that I had up here in this relation. And I've already got them in order from least to greatest. No, I don't. I don't have those in order from least to greatest. So I'm going to switch the 4 and the 1. But then the other part I'm seeing here is we do not repeat. So because I've got 2 4s, I'm going to eliminate that 4. And then I'm going to put, you guys know I suck at making these little curly braces. But that is what the domain should be for this one. We take all the X values, put them in order from least to greatest, and do not repeat if you have the same number that comes up twice. So now the range is the same thing as the dependent variable, output, Y value, range. It all means the same thing. So in algebra, though, we're primarily going to use the term range. And it's not your biggest minus your smallest like it was in statistics. Okay, it's going to be your Y values. Once again, least to greatest. It would help if I spelled least right. And we do not repeat if that comes up. And it needs to be in those curly Q braces that I can't draw. So looking up at my Y values, so you see we had 3, 5, 6, and 9. So 3, 5, 6, and 9. And actually, they're already in order from least to greatest. And so I just need to put the little curly Q braces around them. So this is everything that we're asked to do for a relation. We need to know that the ordered pairs, how to put them into a mapping. So you literally just take your X and your Y coordinates and put them into, the X's go on the left, the Y's go on the right, connect them with arrows. We know how to turn it into a table. We know how to graph it. And we know that the domain and the range just means your Y values and your X values, and they just need to go in order from least to greatest, and do not repeat them.